Ladies and gentlemen, welcome back. I hope you all get charged up for the afternoon sessions. Please be noted that there is a networking event for WIDS and Start Lab from 6:30 to 8:30 in the Good Lab tomorrow after the WIDS Day 2. For details, please check out Internet Society Hong Kong website and remember to register it. Up next, Mr. Josh Abrant, Postmaster at Twitter, will tell us about how to build messaging and personalization at scale. Mr. Abrant, please.
Thank you. So I'm going to do a bit of a case study here on how we've approached one of the scaling our messaging and personalization services at Twitter. Before I get into that, just who I am, I'm Josh Abrant. I joined Twitter about a year and a half ago when Twitter acqui-hired a startup I'd founded called REST Engine. REST Engine was a marketing automation solution for Facebook apps. So I've kind of been playing in the social space for a bit now. I have about 17 years of experience working at San Francisco and Silicon Valley startups. I get asked a lot, what is the postmaster role at Twitter? People aren't necessarily familiar with what a postmaster does. So we have multiple teams at Twitter that work on email projects, work on messaging projects, creating different services around that. And I work with all of them sort of as a project manager, a product manager. I also maintain relationships with all the receivers that receive our messages, inbox providers. I'm responsible for some of our messaging security and some of our anti-spam efforts. So messaging at Twitter, our last public announcement was that we have just over 200 million monthly active users. We give users, users have a lot of control over what kind of messages Twitter will send them, how they receive those messages and how. I like to say all the time that SMS and email are very much the lifeblood of a social network like Twitter. While the timeline is the key of Twitter, a lot of people tend to interact with Twitter through email and SMS. And so something we're also starting to focus more on is, of course, is push. Push to the iPhone, push to the Android phone, push to the Windows phone, and so forth. Just before I kind of get in and talk about how we built our messaging platform at Twitter, just kind of talk about what kind of messages we send. For the Twitter users out there, you're probably aware that we have a very rich SMS experience. Indeed, you can pretty much fully experience Twitter through SMS. You can receive tweets, you can reply to tweets, you can direct message people, and indeed we have millions of users that solely interact with Twitter through SMS. They tend to be in developing countries that have less access to the internet, but SMS has been one of the key foundations of Twitter for quite a long time now. The kind of messages we send through SMS are typically triggered messages, a tweet, a reply, those kind of things. And those are naturally personalized. If I'm sending a tweet, it's the tweet I'm sending, it's personalized. We also send a lot of email messages at Twitter, and so we have a lot of notifications. If you want, you can have Twitter send you notifications by email of when someone retweets you, when someone mentions you, if someone favorites one of your tweets, when you get new followers, when there's a direct message that's been sent to you. And again, these types of messages are naturally personalized. The content of the message is created, personalized to begin with. We also send a lot of email digests where you can sign up for things like you might want to see the top tweets you missed or updates on activity of your network, who to follow suggestions. Who to follow suggestions are actually very important to Twitter. A lot of our users, when they sign up, don't have much of a timeline. They're not following many people. They don't know who to follow. And unless you're following people on Twitter, you're not going to get much value out of it. So that's a very important kind of digest. Now, personalization on these kind of digests is very challenging. They're not naturally personalized, so we have to pull a lot of signals to figure out what are the top tweets that might have interest to you, who are the people whom you might be most interested in following. These digests are also, unlike the kind of triggered notifications, they're much less real time. You can sign up for digests usually on a weekly basis. Most users do that. You can also sign up for them on a daily basis if you want. One way to think of them is they're personalized bulk messaging. And we have to personalize these messages. We have to look through all the signals and look through the signals and all the data we have, which is quite a lot of data. Last point before I kind of jump into the architecture of this here, one of our goals is to prevent user fatigue. And I think there was some discussion of that during the kind of conversation about not showing too many ads, not showing too many of this. And that's really a key consideration we have at Twitter with everything we do. How do we prevent user fatigue? We don't want to fatigue our users. We want them to enjoy Twitter. If we send them too much of any particular type of message, they might get fatigued, or even worse, they might get annoyed. And so how do we prevent that? That's very important to us. And also in messaging, I just want to mention listening to users is very important. For those of you that get Twitter emails, you might notice that at the bottom of our email there's a password reset link. The reason for that is when we started to roll up our email program, users started receiving these emails and said, oh, that's really interesting, top tweets I missed, I'm going to go check out Twitter. They'd go to the Twitter, click on a link, go to the page. They couldn't remember their password because they hadn't been to Twitter for a while. This is actually a really common problem, so we solved it simply by putting a link to reset your password right in there. Making it easier on the users. So key point on that is when you're looking at what kind of messaging program to build for your users, make sure you're listening to your users, collecting the feedback. Now before I jump into that, let's go and take a look at the... Okay, so I'll talk a bit about the architecture we have here at Twitter. And we're very much a big data company, over 200 million monthly active users, hundreds of millions of tweets being generated every day. And when it comes to messaging, we had to build an architecture, a stack that would have many, many places calling in and different types of messages, particularly email, SMS, and now push going out. So how we went about building that is, I should mention at Twitter, pretty much everything is named after a bird. It's actually a bit disorienting when you start working at Twitter because every web service, every database, everything is named after a bird. I had no idea just how many birds there were actually in the world that you could use as a naming convention. And so we have a lot of different kind of web services, generally related to the timeline service, which is the kind of the key service of Twitter, the timeline, which people will see. For those of you that aren't familiar with the timeline, that's kind of similar to the news feed, in fact, somewhat, that Facebook offers. And then we have a lot of user services that might need to send messages to. So all of these flock of services, flock of birds, will make calls in. Now that's more for the triggered type of messages. For the more bulk type of messages, the digests, things like that, those don't need to be so real time, and those are less web services based, but need to really crawl through a lot of data, crawl through a lot of signals. So these tend to be more, I think, to use LinkedIn's term, they're nearline data. And the way we use is we use a language called Pig. Pig is kind of like the sequel of a Hadoop. Hadoop is a stored value pair, a great way to manage a lot of big data. Pig is a language that you can actually use to write queries across Hadoop. So we have all these Pig jobs. Say I want to create a new type of network digest, a favorite activity digest. I'll write a Pig job that will crawl through the data, might take days potentially, and output a set of files. These files will then get outputted and then picked up by what we call IBIS client. IBIS is a bird. In fact, the whole stack I'm talking about is the IBIS stack. That's the only bird name I'm going to use in this presentation because I know it can get confusing to talk about too many birds. And so the IBIS client will pick up these jobs, these files, excuse me, that were generated by these Pig jobs across our Hadoop cluster, dropping these files, and then the IBIS client will actually make web services calls. So the IBIS client makes these web services calls to what we call a routing layer. And the routing layer, although it sounds complicated, is actually fairly simple. It really does one main function, and that is to dedupe messages. When you're maybe a little sloppy with your Pig scripts or a little sloppy with your web services APIs, it's easy to create multiple copies of the same message. And of course, a great way to fatigue a user is to hit them with the same message over and over again. No one really likes that. So this, what we call a routing layer, really acts as a deduping layer to make sure that there's no two copies of the same message being sent to the same user. Then sitting underneath that, we have orchestral queues. We'll just call them a queuing system. But the queuing system just grabs these messages that have been deduped, puts them in a queue, and then they sit in the queue and wait. And different queues have different priorities. And that's because when you're building a messaging platform, your different types of messages are going to have very different priorities. People want to know right away if someone retweets them. People want to know right away if they get an message in Twitter. Do they need a top tweets from their network right away? I mean, it's nice if it gets out there right away, but it's much less important. So we have the queues that have these different priority system, and as the messaging stack has the throughput to take on these different messages, it'll accept them in and based on the priority of the queues. Now that's actually queuing and priority on queuing is very challenging. We've written a lot of technology here. If you're building a messaging stack, I'm not sure queuing is really the first thing you want to deal with because there's a lot of challenges. Like say I have a low priority message that keeps getting bumped to the back of the queue and never goes out because of that. That's a common problem when you start to look at priority queuing. So we have a number of kind of intelligence that eventually, if a message is bumped too much, it either gets dropped or it gets put to the front of the queue, depending on a number of different factors. So that's our the queues that are sitting underneath the routing layer. Next, they get fed into a relevance layer. And the relevance layer is very important, and it's a lot of kind of the secret sauce. But the relevance layer does a number of intelligence things. Like one, it picks what channel to send a message on. And it can be very intelligent about sending a message. Say you've set it up so that you want push notifications on your retweets, and you also have set it up that you want email notifications on your retweet. But you get the push notification and you respond to it. You take action with it right away. Should we really send you the email notification then? Probably not. Say though, however, you haven't responded to the push notification, you didn't see it, you didn't take action. Well, then you probably may want the email message to come about that. And so the relevance layer will look at what is the best communication channel based on the user's preferences, based on the message, and based on what messages have been sent previously or also in the queue. So a lot of intelligence was put onto that. It can hold on users' actions. And so the relevance layer can say, you know, this user has gotten too many messages, they haven't responded to them. We're going to actually, these are mid-priority messages, we're just going to drop them. We don't want to fatigue the users. Relevance layer is very much where we hope to prevent user fatigue. And so that's the relevance layer. Once things pass through there's a number of other kind of techniques that go into the relevance layer, but the key there is to make sure that the user is getting a message they want and it's relevant to them. And they're not getting too many messages, prevent fatigue. Once messages pass through the relevance layer, we then go on to our processors, which of course are named after a bird, but I'll refrain from the bird names for now. But the processors provide a lot of value here too. One of the key things is to stop spam. And that's a key point. I can't really mention enough. If you do look at building messaging, you really need to consider to not be a spammer. Indeed, when I'm working with the different kind of messaging teams at Twitter, we're constantly having the conversation, is this spam? If we send the user this message, if we send the user this message this many times or this many times, is it spam, does it change? And we tend to be very conservative on that. We want to give users messages they want, prevent fatigue. We also want to stop the outright spammers. So, I mean, the kind of one of the measurements of whether a platform has become successful is, are the spammers on that platform? And do we have spammers on Twitter? Absolutely. We also have several teams that are working on taking out those spammers, looking at different signals to take them out. These processors, one of their key roles, stop the spam. Hey, okay, this is someone retweeted you, but it was a bot that retweeted you. You don't want to know if a bot retweeted you. You want to know if a real human retweeted you. And so the processors, hopefully, will stop all those spam messages before they ever get out. One of the reasons we have that kind of anti-spam check so far down the path, past, say, the relevance layer or past the creation, is because it can be more real time at that point. The processors are the last step before the messages actually go out. And so that's a great place to put in your final kind of anti-spam protection, is right there. Because it's more real time. Indeed, very much the way anti-spam systems work, people report a user, report a bot as being spam, gets flagged as spam. The moment that happens, the processors will know it and they'll stop sending those messages. Other things these processors do will say load user data and customization. So some users will change their data very, very frequently. They might change their profile picture, they might change their background picture, who they're following, things like that. And these can all affect whether a message should go out. On Twitter, you can only receive direct messages from someone who you follow. Well, what happens if you stop following them and there's a message in the queue coming, you stop following them because, I don't know, say they're being abusive or they're cyberbullying you or something like that. Last thing we want to do is then continue to send that direct message. And so the processors load user data and all customization in real time right before the messages are going out. They actually pass queue, and anything that needs to be changed is changed right there and then. Up-to-date recommendations. As I mentioned, who to follow is very important to using Twitter. If you don't have a good follow graph, you're not going to enjoy Twitter. You're only going to enjoy the content on Twitter. I know we had a lot of conversations about who generates content and who owns it, but the content on Twitter is all generated by users. And you decide by who you follow what content you want to receive. So that's constantly changing, and based on these signals, we'll load in those who to follow recommendations right in these processors levels. And then another point, and as developers, this is a very key point, is we do experiment lookups. So those of you that follow Twitter and the news may have heard recently that we have this new policy our CEO came out with very publicly, that it's very easy to launch a 1% experiment at Twitter. And by a 1% experiment is, hey, I have a new way of representing the timeline. I have a new template for the SMS notification. I have a new template for the email notification. I have a new signal I'm going to build into the who to follow recommendations. At Twitter, everything gets tested. I mean, I think actually compliments to Google. Google was really the company that really kind of elevated testing and bringing testing and experimental data into product design. And we very much follow that at Twitter. We have a very open policy with testing. If you want to run a 1% experiment, go ahead. You'll need almost no approval to do so, provided you're, following within company rules and not doing anything illegal, and want to run that experiment and gather a bit of data. And so we do experiment lookups in those times. So it might be that the message is about to go up. We do a lookup. Go, oh, this user is part of the 1% experiment that's going to get the new email template. Let's load this template in at that point in time. And that's done by the processors right before the messages go out. And really, as developers, the idea of experiments and seeing what kind of changes you make and what kind of effects they have on users is very important and can be a wealth of information. And when you're measuring experiments, don't just look at the obvious, but look at the real effects on users. So when we're measuring experiments on Twitter, like let's take the example of a new email template. An obvious metric to look at is, does it get more clicks, does it get more opens? Right? Oh, it gets more clicks, gets more opens, it must be a good template. But what if it gets more clicks, gets more opens, but then users who clicked or opened are less likely to come back to Twitter? Or they go back to Twitter and they unfollow everyone, or they take actions that are negative, showing that they were somehow displeased. And so when you're using experiments, kind of think far out on where the experiment could lead and what kind of data you want to really measure. And we'll measure experiments across the very lifetime of Twitter. Now that's not necessarily easy to do when you have a lot of data, but you always want to be thinking about that. And experimentation is one of, I think, the real keys to optimizing a program. Just to kind of start up for a second, take a step backwards. As app developers, I think your first goal is always find product market fit, right? Find a service, a product, an app that you can build that is providing value. Once you've got that product market fit though, then it's time to start experimenting, right? Product market fit is often intuition, understanding, knowing people, knowing what they need. Experimentation is optimization. How can now that I've got this product market fit, now that I've got an app, how can I make it better? How can I drive more user engagement? How can I make my users happier with my experiment? Once it goes through the processors and everything's been loaded, the message has been customized, then it's time to start and send out the messages. So I mentioned there's 3 different ways we send out messages in Twitter. One is, of course, SMS, as I said, a key way of communicating and interacting with Twitter. We actually own our own SMS gateways. We bought a company up in Seattle called CloudHopper a couple years ago. They run an SMS gateway, all that kind of secret sauce on working with the SMS carriers, being allowed to send messages. They actually run their own set of anti-spam checks there and then at that. So that's how our SMS go out. We also work with Push. Push is a newer kind of addition to the messaging stack at Twitter, but we've now integrated in push with pretty much all of the big players, Apple, Android, BlackBerry, Microsoft, Nokia, and so we can send push messages. A lot of interest there. And push, as app developers, I'm guessing a lot of you are working on mobile development. Push is a pretty amazing thing. Push is interesting though. What we found is that it's very easy to fatigue your users with push. Very, very easy to fatigue your users with push. So be careful about, think about it. This is someone's phone, it's in their pocket, it's in their hand, you're popping up a message. If you pop up a message, it better be valuable. It's a great way to drive people back to your app. It's a great way though, if they don't like the messages for popping up, to get your app uninstalled. So push is a double-edged sword. Be careful, don't ignore it, but be very careful with it. And then of course we use email, kind of the bread and butter of the internet. And we use an MTA, I won't get too much into the email tech, but an MTA is the message transfer agent. It's the kind of piece of software that maintains all the connections with the different ISPs per the way the ISP wants that connections, manages deliverability, deals with bounces, feedback loops. For those of you that are sending email, make sure you sign up for feedback loops. Anyone here familiar with email feedback loops? Or? Yeah, okay. Email feedback loops are a great program for preventing fatigue within email. So almost all the major inbox providers, with the exception of Google, but Microsoft, Yahoo, for example, provide feedback loops where you simply register your sending with them, and they'll let you know every time someone hits the report spam button. This is an incredibly good signal to see if your messaging is working. They just send the message, if someone hits report spam, they just send the message back to you. You can then unsubscribe the person, realize that this kind of message was too spammy. And so that's what the MTA does there, the message transfer agent, and sending out the message. So, going out to your phone, going out to your tablet, going out to your desktop computer, the messages go out. That's our general kind of messaging stack. So there's some of my info right there. Feel free to follow me on Twitter at Jabrant. I also have my own t.co link, working at Twitter, t.co/Josh. But I just wanted to talk on a couple more things related to email, because as app developers, I can't really stress enough how powerful the email channel is going to be. And a number of early apps, like for example, Zynga, came out of nowhere, was one of the fastest growing app developers ever. Heavily leveraged email. Email is an incredibly powerful channel. And it's also an easy channel to use. You don't have to work with these SMS gateways and all that kind of stuff. Almost everyone has an email address. So great way to drive re-engagement, reactivation, those kind of activities is through email. But when you talk about email, there's a number of considerations if you're going to make it work. And of course, the first one, and this kind of gets back to some of the things we talked about earlier today, is security. If your users are going to have no trust for your emails if you can't offer security. And there are now ways to actually implement email security, to actually very easy ways. It used to be when email was created 40, 50 years ago, there wasn't a thought given to security at all. And so it would be very easy. If I wanted to impersonate, if I was a bad guy and I wanted to impersonate twitter.com, I could literally sit at a computer, open up telnet to port 25 and start typing out like I was twitter.com and impersonate it. You try and do that today though, it's not going to work. And that's because of something called DMARC. DMARC is an email security technology, and I'll talk about that more in a sec. But one of the things we did before we deployed DMARC is we went in and measured what kind of email attacks were happening in our user base, and it was around 110 million forgery attack emails impersonating twitter.com and our other domains every day. So a huge volume of attacks and this was going after users, going after our business partners, and just out there generally in email. People impersonating twitter.com, trying to get you to click on a link and go to a page and give your credentials, or trying to get you to click on a link and go to a page so they can drop some malware drive-by. Until 2 years ago, there was no real way to address that. But now there is, and with the technology that's come out, and I'm part of the DMARC org, so that's probably why I'm talking about that, but DMARC, which is the domain-based message authentication and reporting and conformance. Basically, DMARC is a way to declare in your DNS a policy that says if this message is a forgery, drop it. And a number of the major inbox providers, Google, Yahoo, Microsoft, are all honoring DMARC policies. It's very easy to set up. It's literally one line in your DNS. You also have to set up what's called DKIM and SPF, which these days are generally very easy to set up too. SPF is just another line in your DNS. DKIM is a little more complex, but most of the email sending engines out there today, or MTAs, already have DKIM built in. But don't ignore these. If you're going to start to offer email, and I can't really stress enough how powerful email can be at bringing users back to your apps, make sure you do set up DMARC, DKIM, and SPF. It's not a lot of work, and it makes it very difficult, if near impossible, for your domain to be used in forgeries and attacks and phishing and so forth. Like I said, at Twitter, we turned on DMARC first in what's called monitoring mode, which means every time there's a message that fails authentications, the ISPs would let us know. And we were shocked when we saw it was about 110 million attack emails a day. So we turned on DMARC, and we're now down to like 100,000 or so a month. And those are getting rejected anyway. So big win for our users, and that way they can also trust our emails, right? The goal here is if your user gets your email, you're going to send them back to your app. You know, you're showing some activity they missed on your app. You want them to click on that and go back to their app. If they don't trust that, if they think, hey, you know, last time I clicked on this link from twitter.com, it took me to a malware site, and I had to go buy a new computer because I couldn't uninstall the malware, it's not going to work very well. So make sure you set up your email security. We've kind of said that security is the foundation of privacy, but security is also the foundation of trust. So make sure you set up your messaging security. Now, when you talk about push and SMS, it's actually less, while it's more work to set up push and SMS, security is kind of managed by the carriers or by Google or Apple or whoever it is that's managing that. So there's a lot more. So security was built in from the start, unlike email where security kind of had to be tacked on later on. Also, we've had a lot of talk about privacy, and so I did put up one slide here on privacy, and I wanted to just kind of comment on that, as privacy is a big concern for Twitter. We have this core value of protect the user's voice, and so we do that a number of different ways. One is, if you followed Twitter in the news, you're probably aware that we've put up a lot of legal fights where various courts have come after us asking, hey, I want this user's tweets. There's the famous Occupy Wall Streeter whose tweets that the courts wanted, and we spent years in court fighting that. Eventually, the courts didn't necessarily rule in our favor, but at that point, we'd so delayed the process, then we'd informed the users. We very much will fight for our users, and we are very proud of that. We also welcome anonymous accounts. It's interesting, this is something else we talked about today. I mean, everyone wants to own identity on the internet, and we welcome anonymous accounts. If you want to be a dog on the internet, if you want to be a cat, you're welcome to do so on Twitter. You don't have to use your real name. You can use whatever name you want. Also, with that anonymousness, just to also mention, when you sign in with a service like Google or you sign in with a service like Facebook, they're sharing their email address with whatever app or service you're signing in with. When you sign in with Twitter, we don't share the email address. We're only doing an OAuth, and we don't share any of that email address info. So with Twitter, we're providing a higher level of anonymity to our users. Also at Twitter, we honor Do Not Track. So, and we're the only major internet service provider, internet company that does that. Who here is familiar with Do Not Track in the browsers? Okay. Probably some internet companies won't like me saying this, but I suggest you all open up your browsers and make sure, of course, you have an up-to-date browser. You can't be secure without a browser. But go take a look in your settings page. You'll see there's an option to say that will say something like, tell websites I don't want to be tracked, or something like that. Turn on that checkbox, and then your browser starts including with every HTTP request it makes a do not track header saying, hey, don't track me. Twitter is actually the only internet company that's currently honoring do not track. So if you turn that on your browser, we'll start to honor that. And then I also, something else we do for all our messaging is we like to include not my account links. We've had cases in the problems in the past where people, there's this term in the industry, Joe job, where you might Joe job someone, you go sign up their email address for something, and then we'll start sending them emails, and it wasn't really their email address. And one ways we get around that is through confirmation. We confirm our email addresses, but also we include a not my account link in every email we send out, so that if you do get an email from Twitter and it's not related to your account, just click on that link and immediately we'll disattach that email address from that account. Hopefully these are all things that build trust with our user base, that make them trust our messaging more and make them more likely to interact with our messaging. So that's all the slides I had. Is there time for questions, or?
We have Q&A session afterwards. So please, thank you, Mr. Abram.